So Iris, can you help me read under adding number 1?
Add the numerators.
Good. So you're going to add the top if your denominators are already the same. Amy, can you help me read number 2 under adding?
Denominator stays the same.
Good. Number 3, Bridget's not here. Number 3, Kelsey, can you help us read number 3?
Restrictions will make the denominator equal 0.
Good. Remember, we find restriction before we simplify, okay? And then Tyler, help us read number 4.
Simplify by factoring.
Correct. And then now subtracting, everything's very similar. So Sarah H, help us read number 1 under subtraction, please.
Distribute the negatives to the numerator.
Good. And then number 2, Anthony.
Follow the addition steps above.
Perfect. All right. Anybody need more time to copy the guidelines? All right. Let's do 1, 2, 3. The instruction for 1, 2, 3 says add or subtract. Okay. First, look at the denominator. Number 1. Are those two denominators exactly the same? Yeah. So we just go according to. I think my thing is frozen. Okay, you go. According to the guidelines, we're just going to add the numerator together. So when we add the numerators, I'm going to put them together. If it allows me to write, sorry, it's frozen. There you go, now it's back. Okay. So we go 2x plus 7 plus 3x minus 10. So I'm writing the numerators together. And no, you don't have to do it my way. Guys, if you already know how to do these, go ahead and just go all the way and then just box it to find the answer. Do we add the denominator? No, they stay exactly the same. Anything we can simplify on the numerator? Yeah, the 2x's, right? And then the 3x will make a 5x. And then your 7 and a negative 10 will make it a negative 3. Perfect. And then drop down your denominator. Now we have to do what next before we simplify? Restriction. Do we restrict the numerator? No. So what is it? X can never ever be here. Good. So box that up. Next, can I factor anything? No, right? Because on the top, would you agree there's 5x minus 3? They go together. Can I cancel out the negative 3 and the negative 3? No, okay. Remember, we can't cancel when it's an addition or subtraction. We can only reduce when they are multiplying. Now, this one is a subtraction problem. What's different between addition and subtraction? Yeah, so on the numerator, we're going to copy the numerator down, 8x plus 3 minus. I'm going to write this here, okay, and we are going to distribute the negative after this step. And no, you don't have to write this step. You can go and distribute it right away. So after distributing the negative to 2x minus 5, we should have 8x plus 3 minus what? 2x, what else? Plus 5 now, because we have to distribute this negative sign to both of those. All over your denominator of 3x plus 4. So 8x and a minus 2x would now make it a what? 6x. 3 and a positive 5 would make it a 8. All over 3x plus 4. Can we factor anything on either top or bottom? What's on the top that we can factor? A 2. So we take out a 2. What's left? 3x plus 4. Now before we go and reduce, we must state the restriction. Take your denominator. We set it equals to 0. So go ahead and give it a head start. Okay. Restriction is take your denominator, set it equals to 0. Give it a head start, and then I'm just going to call on you to give me what x cannot equal. Once you have an answer, can you confirm with your neighbors? Julian, can you give me the restrictions whenever you're ready, hon? Okay, so x can never ever be negative 4 over 3. Someone disagree with that? No. Now what are we going to do? Simplify, right? Cancel. So we're going to cancel that set and this whole set. That means our final answer is what? 2. I know. How awesome. I love cancellation. Okay. So final answer is dos. All right. Last example on this here. Denominator. Are those the same? Yep. So just, do I need to, when we distribute the negative, since we only have one term, would you agree that it's just going to be x squared minus what? 25. Perfect. Can we cancel anything right now? No. But what can we do? Factor it. Yep, always factor. What can we do in the numerator? That's right. Both of you are right. Okay. X plus 5 times the quantity of x minus 5 because it's different to 2 squares. Anything we can factor on the denominator? 3. What's left? X. Okay, good. Before we go and happily cancel, we must state the. Good. Go ahead and state that for me. What is it that x can never ever be? Good. Now we can cancel out the quantity of x minus 5 and x minus 5. So Liam, what's the final answer, hon?
X plus 5 over 3.
Perfect. And box that up. So when your denominator is the same, they're not too bad. Okay. Now, finding the least common multiple, okay, or the least common denominator. Number 1, Juliet, can you help me read number 1, please? Yeah, always factor it first. Number 2, Logan's not here. Number 2, Audrey C, can you help me read number 2, please?
Find all common factors.
Good. Number 3, Heather.
List the remaining factors.
Good. And Madison, help me read number 4. Good. What do you think? Why do you think we need to kind of revisit this skill? Why do you think we need to know how to find the common multiples or common denominator? What do you think is going to happen in the next couple of examples? Would you need to know how to add and subtract expressions without common denominator? Yeah. So back in the days, okay, if I gave you 1/2 just plus 1 over 5, what did you have to do then? Find a common denominator. You're right, okay? By the way, if you look at it, what's a common denominator? 10, right? What if back in the days, I said, okay, 1/3 plus 1/6. What was the common denominator then? Right, okay. So same thing. 5 and 10, this is example 4. It says find the least common multiple. What do you think the smallest number both of those will have in common? 10, you're right. And this is why it says factor. 5 is really a prime number, so technically just really 5 times 1. And the reason we're kind of breaking this down is so that way we have an understanding of where it comes from. Can you guys agree they both have 5s in there? Right? They both have two, not both of them, I'm sorry. Only one of them have a 2. So to find the least common multiple, or later, least common denominator, first, if it's the only factor, you take it. So 1, we don't need to worry about 1 because 1 times anything is itself. So 2 is by itself. They both have a 5. We don't need to worry about taking both 5s. We only need to take what? One of them. So the least common denominator or the least common multiple is just going to be a 10, which you guys already know, but that's why it is. Now, how about 7 and 9? 7, would you agree 7 is a prime number? So I don't need to worry about factoring that. How about 9? 3. So, but here's the part where what happened when, by the way, 3 times 3, would you agree that's like 3 square? Okay. But here's the part where you have like more than just one of those. Right now, if I said, what is the least common multiples, what do you think your answer is? Between 7 and 9. So back in the days, if I say, okay, back in the days, 1 over 7 plus 1 over 9. Right. How do you know? Exactly, right? Because would you agree that both of those, 7 and 9, they don't have any factors in common, right? So this is why back in the day, we just take 7 and we multiply by 9, which is 63. So when you have a factor that has multiple powers, like repeating power, then you take the highest one, okay? So in this case, we will take 3 squared times 7. That's like 9 times 7. So this one, that's why it's 63, okay? So because we're going back to basic because we would need to use this skill for the Algebra 1 exam below. How about 12? Okay. What if I factor it out? What would you get? You got 4 times 3, but 4 is not a prime number yet, so 4 is really what? 2 times 2. So these are all what? As far as you can go with factoring. And again, we're just going with the basics. And then 20, it's really 4 times 5, yep. And then 5 is as far as you can go, but 4 is really 2 times 2, all right. So would you agree that 2, I have 2 of these over here. Is that the same thing as 2 squares? Yep, okay. Same thing with this. This is the same thing as 2 squared. So right now, your factors are the 3, the 5, and both sides has 2 squares each. Would you guys agree? Do you take both of them? No, you don't take both of them, okay? You only take the highest power, but they're the same. So it doesn't matter which one we take. No. So when you find the least common multiple or the lowest common denominator, you take 2 squared times 3, because that's the only one, so we have to take it when it's the only one. What else are we going to multiply? 5. So 2 squares, 4. 4 times 3 is 12. 12 times 5 is 60. So that's why this is, I know earlier one of you said 60, okay? And guys, if you already know how to find the common multiple, do you need to do all this stuff? No, go straight there, okay? Okay, so now this is leading us to our algebra here. Can we factor anything out from 2x plus 14? Yep, what are you going to take out? 2 times x plus, good. Now over here, you're going to take out what? 3, and you're going to have x plus 7, okay. Would you agree your least common multiple, I have to take a 2 because it's by itself. I also have to take a 3 because by itself. You have x plus 7 on each side, and they're both the same power. Do I have to take both? No, take one, okay? So that's times x plus 7. So our final least common multiple is going to be 6 times x plus 7. And no, you don't have to distribute those. You can leave them. Now on 8, you have x minus 1 and x plus 2. Do they have anything in common? No, they are both prime themselves. So guess what the least common multiple of that will be? Take both of those, okay? If you take both of those, again, you do not need to distribute, okay? 9. What do you do on 9? You have to do what first? Yeah, you got to factor to see what the prime. Okay, so x squared minus 9 is the difference of 2 squared. So the factors are the quantity of x minus 3 times the quantity of x plus 3. 4x plus 12. What are the factors there? Take out a 4, and then you're left with? Good. Okay. Would you agree x minus 3 is the only factor of its kind from both sides? So you take it. Okay. If it's all by itself, you take it. Would you agree you have x plus 3 from both sides? Did you take both? No. Take the highest power, but they're the same power, so just take one. Is 4? Do we take 4 or do we leave 4? We take it. Okay. So you can leave it like that. Or some of you can see that this is the same thing as x squared minus 9, and you can leave that like that. You can even distribute further, like 4x squared minus 36. Okay, that's really your personal choice. All right, flip over. Okay, go ahead and now we're about to do something a bit more. Okay, write those down, and then probably, how many examples do we have on this page? 3, okay. Is that the end of this deal? Are there more in the back?
Subtracting.
Oh, for subtracting. Okay, thank you. All right, I'll put 2 minutes. I don't want to go too fast. So we'll put 2 minutes on the clock for you to copy this.
If you need more time, after 2 minutes. Now, if you guys are new to the class, I try to record lectures for you. Sometimes the computer just doesn't want it.
But when it does, you can check them out on YouTube if you're ever absent.
Do we need more time?
Yeah, for sure. We'll put another 2 minutes on.
If you come from a class that's already studied or, worked on these, go ahead.
Anyone not done so I can have more time? So here we go. Adding. First is adding. It says 3 plus a fraction of x plus 5 divided by x. 3 doesn't have a fraction. How do you make it into a fraction? Yeah, put it over 1. Well, look at the denominators. Are they the same? No, right? So what do you think the common denominator is? Yeah, so this one, LCD is x. Okay. So what are you going to do to the 3 over 1? Multiply by x. What you multiply to the denominator, you must multiply to the numerator. So we will take this, multiply by, oops, not 3, but x. It's frozen again. There you go. Multiply this by x and multiply by x. So if we multiply top and bottom by x, there you go. On the numerator, Jake, 3 times x will give us what? 3x, okay? Over x. Plus, over here, we do not do anything on the right because it already has a denominator of x. Now what do you do here? Do we combine the top? Yeah, so let's combine the top. On the top, we have 3x plus 5 all over x. How many x's do you have on the top? 4 x's plus 5 divided by x. We now should find the, what is it that x can never ever be? 0. Can I do anything else with 4x plus 5 divided by x? No, so box that up. Oof. Number 11. 5x minus 6 divided by x squared minus 4x plus 7 divided by 3x minus 12. Okay. We should try to do what according to guidelines? Factor. You're right. So 5x minus 6, I cannot factor that at all, so I'm just going to copy that over. X squared minus 4, what can we factor there? Good. Take out an x. You now have an x minus 4 plus, this is now a 7 over here, can't do anything there. 3x minus 12, what can we factor? Take out a 3. So we have an x minus 4. Okay. So just look at the denominator, just like earlier when we're looking for LCDs. You have x. To find your lowest common denominator, do we take it for our lowest common denominator? Yeah, right, because it's all by itself. You also have 1, 3. Do we take it? Yep, multiply by 3. You have x minus 4 on both sides, and they're both the same power of 1. Do we take it? Yeah. Do you take both? No, just 1. Okay. Now you make this pretty before you. Okay. So 3x times the quantity of x minus 4 is your lowest common denominator. So we go over here and write 3x times the quantity of x minus 4. 3x times the quantity of x minus 4. Now before we go further, we have to analyze. What did we change from the first fraction? Look at this. Look at the denominator. What did we change from that denominator to this denominator? Multiply by 3. What you multiply to the bottom, you must multiply to the top. So go and multiply the top now by 3. Okay. Now analyze the second denominator. What did we change there? We multiply by x. So that means on the top, we need to multiply by x. Now we distribute the top. Okay. So when we distribute the top, what do we get on the first fraction? 15x minus 18, and then 7 times x is just simply 7x over my common denominator of 3x times the quantity of x minus 4. Can we combine like terms on the top? Yeah, 15x plus 7x will give us what? 22x minus 18 all over my denominator. All right, can we factor the top? Yeah. What do they have in common? They both are even. So if they both are even, what can we at least factor out? 2. Yep. Let's try that first. Then that means you have what? 11 x minus 9 all over quantity of 3x times x minus 4. Now before we go and reduce, we should, how many restrictions do we have? 2, right? Over here, would you agree that 3x is a factor set equals to 0? That means x can never ever be 0. Over here, x, it's minus 4, it's a factor. Take that. Now, when you have multiple factors, make sure you separate it using a comma. X can never ever be 0 or 4. So you have both of those. Can we reduce it all? No? So can I just box it up? Okay. All right. We'll stop right here. I'll let you guys work on your homework 8.